Okay, hello. Can you hear me? Is the microphone working? Great. Okay, so hello everyone. I'm Amber, and as Amelia said, I'm studying wildlife conservation. It is a top-up year that's based at Northumberland College that's awarded by Cumbria University. So it's essentially like I'm doing my third year of degree, and I decided to do my dissertation research on small mammal trapping at Gosforth Nature Reserve. So I'll walk you through the methodology that I used and some early observations. It is a still work in progress project, so I don't have any conclusive results right now. But I thought I'd start off by talking about the existing records of small mammals at the reserve. So we have 3 native shrews in the UK, and they're all insectivores. They are all protected as well by the Wildlife and Countryside Act, so you do need a licence if you do want to trap shrews. And that's because they have a really fast metabolism. Common shrews and pygmy shrews actually need to eat the same body weight as themselves each day. And actually pygmy shrews can eat up to 250 things a day, which is very impressive. So the pygmy shrew is the smallest land mammal that we have in Britain. And the water shrew is the largest one out of the 3. A really good way to identify them between, I hope you can see this, yeah. So between the common shrew and the pygmy shrew, the common shrew has more of a tricolour fur, and the pygmy shrew is sort of like green-brown on the top. Also, another way to tell them apart is the pygmy shrew has a much longer tail. The tail is about 70% of its body length, whereas the common shrew is about 50%. So that can be quite handy, especially if you're looking through black and white videos on a camera trap, which is what I've been doing. And the water shrew is the largest one, as I said. It's also got this really striking black fur as well, so that can be a good way to tell it's a water shrew. A nice little fact about water shrews is that they have venomous saliva, and that's to stunt their prey. So if you actually get bitten by one, you just get like a little rash on your skin, but I just thought that was quite impressive. So next I'm going to talk about mice and voles. So these are the 3 that I expected to find on my research. I know that we have water voles, although there hasn't been one sighted at the reserve since 2019, so I didn't include that. So the wood mice, it's our most widespread and common small rodent, and it has this really lovely sandy fur, and it's very adaptable in loads of different habitats, so you might see it everywhere, and it's quite abundant. The bank vole and the field vole, they're very, very similar looking. Again, one way to tell them apart is the bank vole has this really nice little red hue on the fur. Also, field voles, another name for them is short-tailed voles, because their tails are shorter than bank voles. So field voles' tails are about 30% of their body length, so that can be a good way to tell them apart. And generally you can find them, you can find field voles in woodlands, but they sort of prefer like arable lands and grasslands and things like that. So that's just some of the small mammals that I expected to find for my research, but I just wanted to talk about why. Why did I pick small mammals? Why is it important? They play such a vital part in the ecosystem. Some of them can play a part in soil aeration and seed dispersal, but also they play a vital part in the food chain. They're a vital food source for predators like kestrels, owls, foxes, stoats, weasels, etc. But on the flip side, they also keep the prey in check as well. So if you took them out of the ecosystem, there could be cascading effects. Also, they're bioindicators as well, and by that I mean they can show signal shifts in habitat health, whether that's habitat fragmentation, degradation, habitat loss. They're also really sensitive to temperature and rainfall, so that could be a signal to climate change as well. And they also can show pollution levels as well, because they accumulate heavy metals and pesticides from their environment and also prey. And And also generally, we just have quite a lack of data on mammals in general, but especially small mammals. They're really elusive, they're really small, they're hard to see, so I just thought it'd be important to get some up-to-date data. Also, as Amelia mentioned, I used to work for NHSN, and the Nature Reserve has a nice place in my heart, so I just wanted to do my research there, and I just wanted to help get some more data that could be uploaded to Gosforth World Web as well, because I know how important it is to have that data and how it can play a part in planning applications as well. So that's why I chose this subject. And I just came up with a few research questions. First and foremost, what are the current surveying techniques? I am going to focus on Longworth traps, which is pictured here in this photo, and also camera trapping, but a modified version of camera trapping, which I will sort of go into soon. Also, I want to look at the historical record of the species at GNR as well, and I'm going to get that from Eric Northeast, and I hope to use that somewhere in my dissertation. I also just want to know what's there right now, and I want to compare these two surveying techniques to see which one is more effective. So I just thought I'd include a map of GNR in case anybody here hasn't been. If you haven't, I highly recommend it. So it has a really good variety of habitats. You've got plantation here, woodlands, wet woodlands, obviously you've got the lake and wetlands and reed beds. There is also a meadow over here, and there is a new meadow that's been planted here. I did get some guidance from local naturalists, namely Chris Wren, who does a lot of camera trapping at the reserve, and he sort of helped me figure out places. I also got a lot of help from Veronica Carnell, who's amazing at what she does, and we did together go and have a look at this meadow to see if there were any signs of field voles, but we couldn't find any. So what I decided to do is I sort of based my trapping sites quite close to the entrance on this sort of red line here. So I've just kind of zoomed in. Sorry if it's really pixelated. So I decided to choose 4 trapping sites in 4 different habitats. And you might think, why did you choose such a small amount of space when you have such a big reserve? But I also had to think about the safety and accessibility as well, because I was working with a team. We were also checking traps 3 times a day, so it's a lot of labour, a lot of walking around the reserve. So I just thought it'd be easier if it was quite close to the entrance. So the first site was near the Lawrence Hyde, the feeding station. So that's like in the woodland habitat, and I thought it'd be interesting to include one that was sort of near human structures and things like that. The second one was sort of on the woodland edge, and I know Veronica said that she had a lot of luck with getting things along there, so we thought we'd go there, and that's kind of the eco-loo, if you know where that is. And then the third site was at the meadow area that I mentioned. Next door to the reserve, there's like a farmer's field, so I was kind of thinking maybe the field voles might come there. That might be a good opportunity for field voles. And then the fourth place was along to the Ridley Hyde here, so that was in the reed beds, and of course I thought that would be a great place to get water shrews. So I'm just going to go over my methodology. So as I said, we had 4 trapping sites with 4 different habitats. Each trapping site had 1 camera trap and then 4 Longworth traps. So there were 4 camera traps altogether and 16 Longworths altogether. And there was a week-long pre-baiting period. During this time, I did have the cameras on, just because you can do that with cameras. But we didn't start live trapping until the week after, and the cameras were also on at the same time. And we did this in late October, early November last year. I know that the best time to trap some mammals is usually April to September, but it's just how it worked out with my course and getting ethics approved and things like that. All the traps were baited with blowfly casters, also apple and carrot and sunflower hearts. And that kind of bait came into play again with the shrews because they're protected, they've got such a high metabolism. They needed that nutrients and that liquid source as well, so that was really important. So this is the camera trap box the sort of modification that I was talking about earlier. Now, this is based on a study by Nick Littlewood, who created this in 2021, and he set this out in Scotland, and it worked really well. I did ask his permission. He said, yes, I could use it. Also, this picture is very misleading. I did not build them all. I turned up to the reserve, and Brian Rutter and Chris Wren had already built 3, and then they guided me through drilling the other ones. So thanks to them for helping me build these. So on the actual camera trap itself, I put +3 lenses on. I essentially just bought some prescription glasses and just popped off the lens, and then I put blue tack on. And that just meant that it could take really close-up videos. And the tunnel just meant that the camera had something to focus on as well, because that's where we put the bait. So it was a pretty good design, and it was very easily just attached with a bungee cord here, and then there's like a perspex roof as well. And it has been shown to be successful in other studies, although it's been a different kind of design. There's been studies in the Netherlands where they've used like a PVP pipe, and also in Australia they use something similar called the selfie trap, which is a great name. So this kind of thing is working, and it seems to be a really good way to look at small mammals. And just for the settings, I had it to take 10-second videos, and there's a 5-minute delay. The reason why I went with videos and not photos is because I thought it would be easier for me to identify the animals, and it worked quite well. And then the live trapping. So we use Longworth traps, which is quite a traditional method of small mammal monitoring. And as I said, we check them 3 times a day, so 6 a.m., 2 p.m. and 10 p.m. This was quite labour intensive. I was very tired for the whole week. But we filled them with meadow hay, soft bedding, mainly for the shrews, to ensure that they were protected from the elements. And the traps were propped at an angle so that any liquid would drain out as well. We didn't handle any of the animals. We just emptied the traps into bags. The bags were kindly lent to us by Veronica. And we all worked under the general license, which I mentioned earlier, and we were all fully trained on using the traps as well. So I just wanted to highlight my research team and just to give them a big thank you, because I would not have been able to have done this without their help. So Kath, Richard, Veronica, Jane and Chris, thank you so much. You dedicated so many hours and so much effort into helping with the live trapping, so thank you. So I just want to talk about some early observations. As I said, I don't have any results at the moment, so this is just sort of what I've noticed, like the trends. For live trapping, we seem to have only caught 2 different species, which are bank vole and wood mouse. It's quite interesting that we didn't catch any shrews, considering the previous records of shrews. So that's it wasn't a letdown, but it just was quite surprising, I guess. But information is good either way. The camera trapping, I did kind of guess this would happen, but probably most frequent visitors were rats and grey squirrels, and also the wood mouse as well. I did kind of figure that would happen. It's just what happens. So, but we also found other species as well. We found shrews, and of course there were false triggers, camera faults, and there were non-target species like birds that came in as well. So even though we don't have many videos of the shrews, I thought I would include some because they're really cute. So as I said, the cameras were rolling during pre-bait, which is really good because then we have this evidence that there are shrews there. It doesn't seem like it's very interested in the food, and I do wonder if this is why we didn't catch any shrews, and maybe I got the bait wrong or something. Oops. So we've got another shrew. I think they're both pygmy shrews that we've got. Again, not very interested by the food. And then this was actually during the trapping week. So this was at the woodland edge. I think that's a pygmy shrew as well. and some slugs. So yeah, I don't think they were very interested in the food. I don't know if maybe the casters weren't the right type or something, I'm not really sure. But then this next one's quite exciting. So we did capture a water shrew on the camera and in the reed beds, of course. And then a bank vole comes in. I'll play that again and see if you can hear it chirping. So I don't know if, again, it doesn't like the food, or maybe it heard the bank vole coming and that's why it left so fast. I'm not really sure. So again, I haven't really gone through all of the videos with a fine-tooth comb, but it seems like that's the only video of the water shrew that we have. So with every research project, there's limitations and challenges, so I just wanted to discuss those. We had a lot of trap disturbance happen with the Longworth traps. We thought at first it was squirrels, and so we changed from apple to carrot in hopes that would work. It didn't work, so then we moved them to a different location but in the same habitat. They still broke the traps open. And then I should have thought about this as soon as possible, but on the last day I positioned another camera trap, a Longworth trap, in order to try and capture the culprit. But then I ran out of battery, and so I still don't know who or what opened these traps. So unfortunately, this was quite a common occurrence over the week, and it was quite disappointing because it means that a lot of the data I have is zeros. So it just means that I have a really small sample size, which limits the analysis that I'm going to be able to do. Also, there were a couple of times we had to leave them open because of rainfall. It was in the reed bed area and we didn't want the water getting in or anything like that. But as I said, these things just happen. If you're working with wild animals and out in the field, some things you just can't predict. So I just wanted to do a little pros and cons of both of the trapping techniques. Obviously with the Longworth traps you have opportunities to actually handle the animals. You can sex them, weigh them, you could even take a DNA sample. You can very, very much get a good identification as well. You can measure their tails and everything. And I guess that would be good for someone looking for population density and things like that. But on the flip side of that, there's ethical considerations of handling wild animals. It's very labour intensive as well. You have to go and check on them and see if they're all right. But also, if you do trap one, you can trap another animal until you come back and open the trap. So it really limits you on what you can see, and you might not catch all the species that are actually there. You might also accidentally catch a pregnant female or an animal that's on the brink of death or something. So it does have these considerations, and obviously a massive con for my project was the disturbances as well. So looking at the camera trap box, the pros, it's non-invasive, you don't have to handle the animals, and you can constantly just let it run. And this was great, especially in the pre-baiting period as well. And it captures a much wide range of species. But on the flip side, there is limitations to seeing what those species were. The camera might come on too late and then the animal's already out. And you just catch maybe a foot or a tail or something, so you can't fully know what it is. And also there were camera failures and false triggers. And of course, going through hundreds and hundreds of videos is really time consuming. So you have your goods and bads, but I think from doing this project, I do think that the camera trap boxes were much more reliable at capturing small mammals, definitely. So just going forward, I'm going to go through all of the videos, and we also took pictures of all of the animals that we caught in the traps, in the Longworth traps as well, and I'm going to upload them to Gosforth Wild Web on iRecord. I'm going to hopefully compare some data through statistical analysis. I'm not sure yet what data I can compare, just with the small sample size of the Longworth traps. It could be that I bring in that historical data from Eric and maybe compare those. It could be that I compare the habitats. And I was thinking I could maybe do a cost analysis as well of both techniques. and then I'm going to really talk about those limitations and suggestions for future research as well. So just before I finish, I just wanted to say thank you again to the research team and all of their help and guidance. I could not have done this project without your help, so thank you. And Brian, thank you for helping me make those camera trap boxes and showing me how to use a drill properly. I just wanted to thank my lecturer and dissertation tutor, Leah. She really kindly lent all of the Longworth traps that we used, and she helped train me and Kath on using them too. And I also want to thank my other lecturer, Dan, as well. He's been really supportive with the project. Friends of Kirkley Hall, they helped fund some of the materials, like the bait used and the bedding. So thank you to them, and of course thank you to NHSN just for letting me do my project at the Nature Reserve, and just for always being supportive and also letting me use their camera traps, because again I wouldn't have been able to have done that without them. So thank you very much.